A classifier is an algorithm that maps input data to a specific category or class. It's essential for tasks in which decisions need to be made, such as identifying whether or not an email is spam, or determining whether an image contains a cat or a llama. This type of algorithm is crucial in various applications, from medical diagnostics to fraud detection. In 2020, scientists developed AI classifier systems that were better at identifying breast cancer than human doctors. There are several types of classifiers, each with unique characteristics and applications. Two popular classifiers are naive Bayes, which work by applying Bayes' theorem using an assumption of independence between features, and support vector machines, SVMs. These find the optimal boundary with which to separate different classes. The naive Bayes classifier is based on Bayes' statistical theorem and assumes independence between features, such as the number of windows in a house and the color of its front door. Despite this naive assumption, the classifier performs remarkably well in many practical applications. It's especially useful for text classification tasks. The strength of naive Bayes lies in its simplicity and efficiency. By calculating the probabilities of different outcomes based on input features, it makes quick and reliable predictions. You can have a go at this in the skills section. Support vector machines are powerful classifiers that work by finding the best separation of data into different classes using hyperplanes. SVMs are particularly effective in datasets with many dimensions and are used in applications such as image classification and bioinformatics. They are capable of handling both linear and non-linear classification tasks by using kernel functions to transform the data. We've already discussed decision trees, in which each node represents a criterion based on an input feature, leading to branches that signify potential outcomes. Random forests take this to the next level. They combine diverse trees, each trained on a unique subset of the data. These multiple trees then collaborate and their predictions are aggregated with averages taken for regression problems and majority votes for classification ones. This mitigates the risk of overfitting seen in individual decision trees, meaning that the model is more accurate and deals better with new data. It's easy to forget that classifiers are not just limited to binary classification. They can handle multiple classes as well. Remember the iris dataset that we looked at previously? A classifier can categorize these flowers into 3 species according to their features. In multi-class classification, the classifier learns to differentiate between more than 2 classes. This requires an understanding of the unique features of each class and making accurate predictions, which is more complex and requires some of the functionality in these more advanced architectures.